Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the transformations of linear functions, and this is part two of a two-part lesson. In our previous lesson, we explored how the linear parent function can be transformed or changed by adding or subtracting numbers to either the input or the output values. In today's lesson, we will explore how the linear parent function is transformed when we multiply its output values by numbers that are greater than 1 and by numbers that are between 0 and 1. So in our first example, we have the parent function f of x. It's shown in the graph on the right. And we also have a table for f of x equals x. So when f of x is equal to x, I've chosen 3 points for you to consider: -4, 0, 0, and 4, 4. In our second function, g of x, they want you to take f of x and multiply it by 2. So what that means is I'll take this f of x value and I'll multiply it by 2 to get my new g of x value. So -4 times 2 would be -8. Then take your next f of x value, 0, and multiply it by 2. Well, 0 times 2 is still 0. And then take your third f of x value, 4, and multiply it by 2. So 4 times 2 gives me 8. Now let's look at what the graph of g of x is going to look like. So I'm going to graph it in blue. -4, 1, 2, 3, 4. -8 would be down here. 0, 0 would still have the same y-intercept. And then 4, 8. 1, 2, 3, 4, and 8 would be way up here. So here is our g of x function, all right? Now, for h of x, they're wanting you to multiply your f of x values. This time we're multiplying by 1/4. So I'm going to change colors here. I'm going back to my original f of x value, -4, and I want to multiply that by 1/4. So that would be, let's change to red, -1. 0 times 1/4 is still 0, and 4 times 1/4 is 1. So I'm going to plot h of x in red. So -4, 1, 2, 3, 4, -1 would be right here. 0, 0 would still have the same y-intercept, and 4, 1. 1, 2, 3, 4 over 1. So this function looks something like this. So here is g of x. So in question A, it says find the y-intercept for each function. So notice the y-intercept stayed at 0 each time. So 0, 0, 0, 0, 0, 0. The y-intercept did not change. What did change was our slope. So the slope of our parent function was 1. The slope of g of x was 2, and the slope of h of x was 1/4. So it says summarize the effects on the parent function when we multiply the output values of the parent function by a constant value, which we will call a. So I'm going to say the parent function got steeper or flatter when multiplying it by a constant value. It did not move it up the y-axis or down the y-axis. It did not move it to the right. It did not move it to the left. All it did was stretch or compress the y values, all right? So in this box, it says, how does the value of a affect the graph of f of x equals a times f of x? Well, when a is bigger than 1, for instance, up here when a was 2, notice that's the blue line. Notice that all the y values got stretched. We went from -4 to -8. We went from 4 to 8. So the y values were, we say, vertically stretched by a factor of, which I'll abbreviate BFO from now on, by a factor of A. So if your A value is 3, you'll multiply all the Y values by 3. If your A value is 6, you'll multiply all the Y values by 6. And the graph is going to appear steeper because those Y values were stretched. Now, what about when the value is A? When the value of A is a number between 0 and 1. For instance, up here we had a value of A of 1/4. So if your value of A is a number between 0 and 1, then the function will vertically compress. That means it's getting closer and closer to the x-axis by a factor of A, and the graph will appear flatter. Okay, so A bigger than 1, it'll be steeper. A between 0 and 1, it's going to appear flatter. Okay. Example 2. Two students transformed f of x equals x as shown below. Use the graph to answer the questions. So in question A, it says, Marissa graphed g of x equals 2/3 times f of x. Label Marissa's line. So we have to determine which line is Marissa's. Now they gave you a clue because they said that your value of A is 2/3. And what we know is 2/3 is a number that's between 0 and 1. That means we're looking for a line that gets flatter. So now we know this would have to be Marissa's line because it compressed. It got closer and closer to that x-axis. Question B. Josh graphed the second line. Label Josh's line h of x and fill in the blank to represent Josh's line. So here's h of x. We want to know what is the value of A. To get the value of A, you're going to find the slope. So here's 0, 0. Let's find another friendly point on Josh's line. How about this one? So we're going up 1, 2, 3, 4, and over 1. So that would be 4. We know the value of A is 4. So what that means is they're multiplying all of the Y values by 4. Now, we want to write a function to describe Josh's line in terms of f of x. So Josh's line is labeled h of x. So we're going to say h of x equals. And we want to take 4 and multiply it by f of x. So 4 times f of x will give us that steeper line. All right. Example 3. A student graphed f of x equals x and g of x equals a times f of x. What is the value of A? So I want to find the slope of g of x. Let me zoom in on this a little bit. I need 2 friendly points. I'm going to use 0, 0 in this one here. So we're going down 1 and to the, let's see, down 1 and then 1, 2, 3, 4, and over to the right 5. So A equals -1 over 5. All right, let's look at example 4. A student graphed f of x equals x and h of x equals a times f of x. What is the value of A? So let me get 2 friendly points here on h of x. How about this one? So I'm going down 1, 2, 3, 4, and over 1. So A would have to be -4. All right, why am I not zooming out here? There we go. All right, next question. What do you notice about the direction of the lines when the value of A is negative? Well, notice on g of x and h of x, they're both going downhill. So when A is negative, the lines will decrease from left to right. In other words, they'll be going downhill. The lines are going to be decreasing instead of increasing. All right, now let's explore some functions with two or more transformations. Example 5 says each of the following represents a transformation of the linear parent function f of x equals x. Describe what changes would occur for each transformation. So in problem A, we have y equals 3 times f of x minus 5. So because we're multiplying f of x by 3, that is a vertical stretch by a factor of BFO 3. And we have another transformation here. Let me highlight it. Minus 5. Now that minus 5 is not inside the parentheses. So that means the minus 5 will move down 5. So we had a vertical stretch by a factor of 3 and down 5. All right, look at B. This time we have y equals 2/5 times f of x plus 3. Well, now our value of A is between 0 and 1. So this means we're going to have a vertical compression by a factor of BFO 2/5, and here we have plus 3. So this time we'll be moving up 3. Vertical compression by a factor of 2/5 and up 3. So the line will be flatter and it'll be translated up 3. All right. Now problem C is from what we learned yesterday. We have y equals f of x minus 3 plus 2. This time we're changing the input and the output. So we're going to be moving horizontally and vertically. Now, when your transformation is inside the parenthesis, so this x minus 3 is inside the parenthesis, that means you'll be moving to the right or left. And when it's minus 3, it will mean we will move to the right 3, and then the plus 2 would be up 2. All right, look at D. We have f of x plus 1. That means left 1. And then we have minus 4, down 4. So the number in the parenthesis controls left or right. The number outside the parenthesis controls up or down. Let me say that again. The number in the parenthesis, left, right. The number out of the parenthesis, up, down. Okay. Problem E. Y equals 5/2 times f of x minus 1. Now here, I want you to remember that 5/2 is equivalent to 2.5. So that means because that number is bigger than 1, we're going to have a vertical stretch. So vertical stretch, in other words, it's going to get steeper by a factor of 5/2. And we have an x minus 1 inside the parenthesis. So that would be right 1. All right, problem F. Y equals negative 2 times f of x plus 5 minus 3. So the negative is going to make it decrease. In other words, it'll be going downhill. The 2 means we'll have a vertical stretch by a factor of 2. The x plus 5 is in the parentheses, so that means left 5. And the minus 3 is on the outside, so down 3. So that one has quite a few transformations. All right, example 6. If f of x equals x is transformed to create g of x equals negative 2 times f of x minus 4. Describe the transformations and then sketch. So this, our transformations, if we describe them, it's going to be decreasing. Our new line will be decreasing. It'll have a vertical stretch by a factor of 2, and it will move down 4. So here's what's going to happen. I'm going to take, just to kind of show you, I'm going to take 3 friendly points off the parent function. Okay, and I've got -2, -2. I've got 0, 0, and 2, 2. And I'm going to transform each one of those points. But to transform them, I'm going to be multiplying the y value times -2 and subtracting 4. So here's what I'm going to take -2 times the y and then subtract 4. So here's what that means. The x value here will stay the same, but I'm going to take -2 times -2, which would be 4, and then subtract 4 to get 0. Then I'll take 0, multiply it by -2, which is 0, and then subtract 4. And now I'll take 2 and multiply that by -2, which is -4, and subtract 4, which would give me -8. Then I'll plot those new points. So -2, 0 would be right here. 0, -4, 1, 2, 3, 4 would be right here. And 2, -8. 1, 2, 3, 4, 5, 6, 7, 8. So here's 2, -8. So this would be g of x. So notice that it's decreasing, it got steeper, and it shifted down 4 units. Okay. So in example 7, we have if f of x equals x is transformed to create h of x equals 1/2 times f of x plus 3, describe the transformations and then sketch. So now I'm multiplying 1/2 times each y value and then adding 3. So if our original points on the parent, now these are points on the parent function. -2, -2 was on the parent function. 0, 0, I'll plot them for you so you can see them. -2, -2 is on the parent function, and 2, 2. And then 2, 2. I'm going to transform each one of those points. Now I'm not changing the x values. Okay, I'm just changing the y values. So I'm going to take this -2 right here. I'm going to multiply it by 1/2 and then add 3. So -2 times 1/2 is -1, and -1 plus 3 is +2. Now I'll take the 0, multiply it by 1/2. 1/2 times 0 is still 0. 0 plus 3 is 3. So this would be 0, 3. And then I'll take this 2. 2 times 1/2 is 1. And 1 plus 3 is 4. So let's plot those. Let me change colors here. -2, +2. 0, 3. And 2, 4. So this is h of x. So our line got flatter. I'll write this down. And it was vertically compressed by a factor of 1/2 and then shifted up 3 units. So vertically compressed by a factor of 1/2 and then shifted up 3 units. And that concludes today's lesson, Transformations of Linear Functions, Part 2.